So in this video, we're gonna talk about zero and negative exponent. So what is zero exponent? So let's talk about zero exponent first. In zero exponent, if a is a non-zero real number, then a raised to 0 is equal to 1. So in short, whatever the value of your a, or whatever the value of your base except 0, the answer is 1. Like for example, 2 raised to 0 is equal to 1. 3 raised to 0 is equal to 1. 100 raised to 0 is equal to 1. 10,000 raised to 0 is equal to 1. And in variable, let's say x raised to 0 is equal to 1. Z raised to 0 is equal to 1. Y raised to 0 is equal to 1. D raised to 0 is equal to 1, and so on. As long as your base is a non-zero real number, the answer is 1. But take note that if 0 raised to 0 is not defined, because 0 raised to 0 is not defined. So that's what we call the zero exponent. So now let's talk about negative exponent. In negative exponent, if a is a non-zero real number and n is any positive integer, so a raised to negative n is the reciprocal of a raised to n. So we have a So that is what we call the negative exponent. A raised to negative n is equal to 1 over a raised to n. Get the reciprocal of this. So the reciprocal of this is 1 over a raised to n. And change the sign of your exponent since it's negative. When you get the reciprocal, make it positive. So that is what we called the negative exponent. Like for example, 2 raised to negative 3. So 2 raised to negative 3, get the reciprocal 1 over 2 cube. So 1 over 2 cube is equal to 1/8. Another example, 4 raised to negative 2. So get the reciprocal, then 1, and copy the base. And your negative 2 exponent will become positive 2. So we have 1 over 4 squared is equal to 1 over 16. So that is what we called, or this, those are the examples of negative exponent. Now you learned about positive integral exponent. There are negative laws. There are different laws involving positive integral exponent. You use these laws in simplifying exponential expressions. So these are the law of integral exponent. First, the product of a power. In product of a power, a raised to m times a raised to n is equal to a raised to m plus n. In short, just simply copy the base and add the exponent. But remember, you can only apply the product of a power if the base is the same or similar. Okay. Like for example, 2 squared times 2 cube. So we have 2, which is 2 is our base, then 2 plus 3 is equal to 2 raised to 5. So 2 raised to 5 is equal to 32. Another example, 4 squared times 4 raised to the 4th power is equal to, again, just simply copy the base, then add the exponent. So we have 4 raised to 6. 4 raised to 6, which is equal to 4096. That is what we call the product of a powers. Next, another law of integral exponent is what we call the power of a quotient. So in the power of a quotient, it's written in the form of the m power of a over b, which is equal to a raised to m over b raised to m. That is the power of a quotient. Like for example, if you have 2/3 squared, so when you apply the power of quotient, it becomes 2 squared over 3 squared. So 2 squared is 4 and 3 squared is 9. So that's the correct answer. You have 4 over 9. Another example, 1/5 cube. Again, apply the power of quotient. So 1 cube over 5 cube is equal to 1. The cube of 1 over the cube of 5 is 125. So that is the correct answer. So that's how to apply the power of a quotient. Next, another example or another law of integral exponent is what we called the power of a power. If power of a power, a raised to m raised to n, or the nth power of a raised to m is equal to a, then m times n. You just simply multiply the exponent, the inner exponent to the outer exponent. Okay, like for example, if you have 5 squared, or the cube of 5 squared. So the cube of 5 squared becomes 5 raised to 6, because when you multiply 2 times 3 is, or the product is 6. So 5 raised to 6 is 15,625. Next, another example, 2 raised to 4, or the fifth root of 2 raised to 4. So 2, then multiply 4 times 5 if we have 2 raised to 20. So 2 raised to 20 is equal to, it's very big, it's super big, 1,048,576. That's how to apply the power of a power. Next, another law of integral exponent is what we call the quotient of powers. In quotient of powers, if we have a raised to m over a raised to n, it becomes, or it's equal to, a raised to m minus n. As long as the base is the same or the base is equal, you can apply the quotient of power by just simply subtracting or get the difference of its exponent. Like for example, 5 cubed over 5. It becomes, since our base is 5, then 3 minus 1 is equal to 5 squared. So 5 squared is equal to 25. Next, another example, 2 raised to 4 over 2 squared. So our base is 2, then 4 minus 2 is equal to 2 squared. So the 2 squared is equal to 4. Next, another example. How about this one? If you have x raised to 6 over x squared, our base is x, then 6 minus 2 is equal to x raised to 4. So that's how you're going to simplify by using the quotient of powers. Next, if you have y raised to 10 over y raised to 6, you just simply copy the base again, then 10 minus 6 is equal to y raised to 4. So that is the quotient of a powers. Next, the last law of integral exponent is what we called the power of product or the power of a product. In a power of a product, you have a, b raised to m is equals to a raised to m, then b raised to m. Like for example, the fifth root, the cube root of 3 the cube root of x and y. So again, apply the power of a product, x cube, y cube. Next, the cube root, the fifth root of m t. No, not fifth root. I mean the fifth power of mt is m raised to 5, then t raised to 5. So that's how to solve or to simplify the power of a product. Okay, how about this one? Try to solve this one. Evaluate each expression. If you have 2 raised to negative 3 times 3 raised to negative 2 times 4 squared. First thing that you need to do is apply the negative exponent. So we have, get the reciprocal of this. So 1 over 2 cubed times another reciprocal of this, because we are using the negative exponent. So 1 over 3 squared, then times 4 squared. And simplify. Multiply the numerator. So 1 times 1 is 1. Then times 4 squared, we have 4 squared over 2 cubed times 3 squared. We have 2 cubed times 3 squared, which is equal to 4 squared over 16 over 8 times 9 is equal to, just simply divide this. You have 2, then 2 over 9. So that's the correct answer. Next, another example. Evaluate each expression. The negative squared power of 4/5. So again, to apply the negative exponent, get the reciprocal. So the reciprocal of this is 5 over 4 squared is equal to 25 over 16. Okay, you apply the power of a quotient. 5 squared over 4 squared, which is equal to 25 over 16. Next, another example. 10 squared times 5 squared. 5 negative 2 times 6 raised to 0. So 10 squared times, apply the negative exponent in 5 raised to negative 2. So you have 1 over 5 squared times, then 6 raised to 0. Next, 10 squared is 100 times 1 over 5 squared is 25. then times. Here, you need to apply the zero exponent. Again, the non-zero real number that raised to 0 is equal to 1. Then again, 100 times 1 is 100 times 1, so 100 over 25, which is equal to 4. So this is now the correct answer. But take note. Oh, sorry. Another example. How about this one? 4 raised to negative 2 over 5 raised to negative 3. Okay? Again, get the reciprocal of each term. The reciprocal of numerator and the reciprocal of our denominator. 1 over 4 squared all over 1 over 5 cubed. Next. In division of fraction to fraction, we always remember that we use the reciprocal or get the reciprocal of our denominator, then use the multiplication operation. So multiply the reciprocal of 1 over 5 cubed is 5 cubed over 1. So we have 5 cubed times 1 is 5 cubed. Then 4 squared times 1 is 4 squared. So we have 125 over 16. Take note that 4 raised to negative 2 over 5 raised to negative 3 is equal to 5 cubed over 4 squared. You just simply change it or get the reciprocal of it. In general, if a and b are non-zero real numbers and m and n are integers, then a raised to negative m over b raised to negative n is equals to a raised to m over b raised to b raised to n over a raised to m. Okay, take note for that. It's very important. So that's how to solve and simplify and evaluate the zero and negative exponent together with the law of integral exponent. I hope that you've learned a lot, and do not forget to like, share, comment, and subscribe on my YouTube channel for more videos and informations to learn and ideas to learn in mathematics.